LDA. LDA stands for linear discriminant analysis, or LDA is used to convert the original data matrix onto a lower dimensional space, that is higher dimensional space to lower dimensional space. और जैसे कि for example, let X be a matrix of order n into m. If n into m, that means कि X has the elements like X of 1, 1 row, first row, first column, first row, second column, and up to m rows, first row, nth column, right? Similarly, X second row, first column, and dot dot dot, X, nth row, first column, nth row, second column, up to X of order n into m, that is nth row and mth column of order n into m, capital M. Okay, yeah. Now our first step is to convert this original data matrix into half parts. Like for example, if it is of order, let's say number of rows here is 2, and number of columns is let us suppose 11, then it would be a matrix of 2 into 11. Order of this matrix would be 2 into 11. So let us suppose X is the elements like 1, 2, 2, 3, 3, 3, 4, 5, 5, 5, 4, 2, 5, 0, 5, 2, 3, 2, 5, 3, and 6, 3. It is of order 2 into 11, that is 2 rows and 11 columns are there. Now our first step is to convert this original data matrix into two parts. Like the first one will contain the like here if it is 11, so then first one contain the fifth. The first class will contain the fifth, all the 5 columns, and the other class will contain 5 plus 1, that is 6 columns, right? So every time what we have to do, that we have to just divide the matrix into two parts, where one part will be of n number and the other will be of n plus 1, like in two class. If it is 5, then other will be 5 plus 1, like this, and just name it as W1 and this one as W2. Okay, that is the W1 has 5 columns. It is a matrix with 5 columns, and this one W2 is the matrix of the last 6 columns. Okay, now the size of this, what will be the size of this matrix? W1 will be, like let us suppose n1 is the size of this matrix, and n1 is equals to 5, and here n2 for W2, n2 will be 6, that is 6 columns. Now the total size of this matrix would be, that is denoted by capital N, then n1 plus n2 will be capital N, which is equals to 11. Okay, so capital N is equals to, that is total size of this matrix is 11. Now what we have to do, that we have to just check the dimension of each of this matrix, each of this class, I mean, that is W1 is a class of first 5 columns. So the elements in this will be like this: x1 means this one, x1, this is x2, this is x3, this is x4, x5, and the other will be, let us suppose I'm giving as x1 dash, x2 dash, x3 dash, x4 dash, x5 dash, and x6 dash. So x1 has the element as 1, 2, x2 has 2, 3, and so on. Similarly, x1 dash 4 and 2, x2 dash 5, 5 and 0, and so on. Right. This one is for W2 class. Yeah, because W2 has this matrix is the matrix with the last 6 columns. So W1 has this values, and W2 has this value. So what is the dimension of this one? See here, it has 2 rows, so dimension will be 2. Similarly, each of these has a dimension of 2. Similarly, here also the dimension of each is 2. Right. Okay. Now our steps, how we will calculate how we will just convert this original matrix into the lower dimensional space. So our first step is to calculate the value of mu. Mu is the mean, as mu j, that is mu1, mu2, j is from 1 to n, 1 by n j summation of xi. Right. This will be the formula where xj belongs to wj. That means if j is equals to 1, then mu1 is equals to all the values of this. We have to just find the mean of this class matrix and this class matrix separately. So mu1 is for this class matrix W1, which will be calculated as n here is the the size of the matrix. So n1 is 5, the overall size of this matrix, and this will be like 1 to summation of all this, 2, 3 plus 3, 3 plus 4, 5 plus 5, 5, which will be around, after adding all this, we will get the value of 1 plus 2, 5, 9, 9, 5, 12 to 14, 50 by 18, which will give us 15 by 5, 18 by 5, which will be around 3, and 18 by 5, which is 3.6. Similarly, we will calculate the value of mu2 for the class matrix W2, which will the value of this would be 1 by 6, 28 by 12. After adding all this, 4 plus 5 plus 5 plus 3 plus so on. 1 by 6, so it has value something like 4.62, and this one is 2. The second step is to calculate the total mean. Total mean will be like mu1 plus mu2. The formula for this would be divided by n, capital N. Capital N is the total size of the matrix, which was 11. So mu is equals to 1 by 11 mu1 plus mu2. Like the formula for this can be written as, here I have wrote for 1 and 2, like for the value of two classes, like two class matrix. So for n number or for I numbers of class matrices, we can write it as mu is equals to 1 by n summation of xi, where I is from 1 to n, or we can say that summation of I is from 1 to c, here ni mu I by n. Okay. So here n, I did some mistake here. It would be n1 mu1 n2 mu2, n1 mu1 plus mu2 n2 into mu2. So here n1 n2 also be there. 1 by 11, n1 mu1 was, mu1 was 1 by 5 into n1 was 5, 15 by 18 plus 1 by 6 into mu n2 was also 6, 28 by 12, 1 by 11, this is 15 by 18, 15, 18 plus 6 cancel out, 28 by 12, which will be around 43 and 30. If we simplify, then the value will be like 3.9 and 3.73. Right. Now the third step is to calculate compute between the class variants or the class matrix. Let's see what is this. The formula for this will be given as S of B, where equals to I from 1 to C, Ni mu I minus mu I minus mu transpose. Right. We can also write it as, if we have only two class matrix, so we can simply write it as n1 mu1 minus mu1 minus mu transpose plus n2 mu2 minus mu2 minus mu transpose, like this. Okay, which is equals to sp1 plus sp2. This one as sp1 and this one as sp2. Right. What was mu1 minus mu1 we have calculated earlier in the first step, which is around 3.6 minus mu was 3.9 minus 2.73. What it will give value as 0.91, 0.87. Similarly, what will be the transpose of this? The transpose is the transpose of this one. 0.91, 0.87. Now multiply this mu1 by minus mu1 minus mu transpose is equals to minus 0.91, 0.87 into 0 minus 0.91 into 0.87, which will give some value. Right. Similarly, we will calculate this one gives SB1. Similarly, we will calculate for SB2 by using this one. Okay, this into n1. N1 is 5. Similarly, SB2 6 into mu2 minus mu2 minus mu transpose. After calculating this, what we have to do, that our step 4 will be to compute within class variance. That means SW. Formula for SW is given as summation of z equals to 1 to c, summation of I is equals to 1 to n, xij minus mu j, xij minus mu j transpose. Okay, here xij represents the ith sample in the jth class. Ith sample in jth class. That means ith sample were like x1, x2, x3, x1, x4, and so on. And jth class means we have divided the whole matrix into two class 1 and 2. So the value of j will be 1 and 2 only, and this will So from 1 to 2 to 5 and 6. How we will calculate this one? Okay, see. Its formula is like z is from 1 to 2, I from 1 to n, and xij minus mu j, xij minus mu j transpose. So what will be, if I is equals to 1 and j is equals to 1, then this will be x11 minus mu 1 j, and yeah, and this will be x11 minus mu 1 transpose. What is x11 minus mu 1? X11 was 1 and 2. This one is x11, that is x11 okay, and minus mu 1 was what was it? 3 and 3.6. Similarly, transpose of this minus 2, 6.6 minus 6 into minus 2 minus 1.6, whatever value there. Similarly, when j is equals to 1 and I is equals to 2, then x is equals to 2 1 minus mu 1, x21 minus mu 1 transpose. What was x21? x21 was 2 and 3. The answer was 2 and 3 minus mu 1 was 3 and 3.6. So this again similarly we have to calculate for all the samples of I. That means like if j is equals to 2 and I is equals to 1, then the value will be like that will go on summation part. Yeah, that will go on summation part. Like add when j is equals to 1, whatever value will come here, we will just add up, just sum up, and when j is equals to 2 and whatever value we will get here, we will just add both this one and this one together. Like we can say that SW is equals to SW1 plus SW2, where SW1 has the value summation of i's from 1 to n xi1 minus mu 1 plus xi1 minus mu 1 transpose, I mean multiply with transpose. Similarly for SW2. After calculating the value of this two, what we will do? We will just calculate the transformation matrix. The name of we will represent the transformation matrix as W. W, where is transformation matrix? The formula for this will be given as W is equals to SW inverse of this one into SB. Right? After calculating SW inverse and then W, what we have to do, that we just have to find the eigenvalues and eigenvectors. Now we have to calculate the eigenvalues and eigenvectors. How we will calculate that? Let us suppose y has the values, like after calculating all this, the value here will be different, but I'm taking it simply as 1 2 and 3 2, right? So we know how to the formula for calculating eigenvalues and eigenvectors as W minus lambda times I, determinant of W minus lambda times I is equals to 0. Here W is 1 2 3 2 minus this matrix is of order 2 into 2, so identity matrix will also be of order 1 and 2 into 2, so one value of this will be 1 0 0 1 minus and by multiplying the lambda with this, it will give lambda 0 0 lambda. So lambda 0 0 lambda. Determinant of this will give us the value of lambda. Will give the value of the value of lambda will be the value of eigenvalues. Yeah, that is 1 minus lambda 3 2 2 minus lambda as 0. So we can directly say that or by simply calculating, 1 minus lambda 2 minus lambda 3 to 6 equals to 0, which is also equals to 1 minus lambda is equals to 6. Okay, like 2, I'm just simplifying the equation. 2 minus lambda minus 2 lambda plus lambda square is equals to 6, equals to lambda square minus 3 lambda, this is 4 which is equals to 0, lambda square minus 4 lambda plus lambda minus 4 is equals to 0, so lambda minus 4 plus 1, lambda minus 4 is equals to 0. So lambda plus 1, lambda minus 4 is equals to 0. So lambda is equals to 1 and minus 1 and 4. So the eigenvalues are minus 1 and minus 4. Let us suppose one of the eigenvalues, that is lambda 1 is equals to minus 1 and lambda 2 is equals to 4. So we will always take the higher value of higher eigenvalue. That is 4 is the highest among these two. So we will proceed further by taking the value of lambda as 4. Right. Now how we will calculate the eigenvector using the eigenvalue? We have taken lambda as 4. So again using this, like w minus lambda times I into v. V is here the eigenvector equals to 0. So suppose v has the elements as v1 comma v2. So what we have calculated earlier, w minus lambda y was 1 minus lambda 2, 3 minus, it was 1 minus lambda 3, 2 minus lambda, and yeah, multiply with v1 comma v2 equals to 0. Lambda was 4, so we can have put the value of 4 here, which will minus 3, 2, minus 2, right? V2. It is the matrix of 40, 22, 21. So the after multiplying, we will get the matrix of order 2 into 1. So yeah, 3 minus 3 v1 plus 2 v2 and 3 v1 minus 2 v2. Right. So we can say that minus 3 v1 plus 2 v equals to 0. That means v1 can be written as 2 v2 by 3. So we can write v as, replacing v1 with this, 2 v2 by 3 by v2, which is equals to, by taking v2 as common, 2 by 3 1. Similarly, from this equation we can set v1 minus 2 v2 is equals to 2. Writing v2 in terms of v1, it will give 3 by 2 v1. So another eigenvector will be like, after taking v1 as common, 1, 3 by 2. We can take any one of this, any one value. Okay, right. Now after calculating this, what we have to do, we have to just now how we will project the matrix into lower dimensional space. We will use this equation. Vk is equals to y is equals to x into vk, right? Or also we can say that x is the matrix, the original data matrix. For two class matrices, we will represent it as w1 v v2. By v2 we will take only those eigenvectors, like we have used lambda, eigenvalue which has the highest value, and we will use only that eigenvector which has the corresponding to this eigenvalue. We will take that eigenvector, right? So I have taken lambda 1 mostly. We can say lambda 1 or lambda 2. So if I am taking lambda 1, then here the value of k will be 1. So that means the value I am using v1 eigenvector, and directly putting the value of that w1 here, we can find the value of y1, which will be our reduced dimensional space matrix.